Hi everyone. We are Santiago López and David Diaz. We are the group one of the section two, and we are going to explain the practice five, diffusivity of a mosquito repellent. Okay, this report will have five parts. We will have the introduction with the objective, methodology, results, discussion and analysis of results, and conclusions. Okay, now for the introduction, we will explain the diffusivity. Diffusivity is a physical process related to the molecule's transport and commonly is directly related to the concentration gradient. As we can see in the equation, the first fixed law equation, we can use it to calculate the diffusivity flux using the diffusivity constant of both species and using the concentration and the position of the molecules that we are analyzing. And as we saw in class, the mixture nature is a determining factor because the diffusivity can be different if the mixture is, for example, liquid-liquid or solid-solid, or for example, if it's a biological system. In other part, we have the temperature, the pressure, and the solubility, and in the case of this lab, the time that are determining factors for the diffusivity and are directly related, meaning that when they go up, the diffusivity go up as well. Okay, now, what is a mosquito repellent? It's a substance useful to repel mosquitoes. It works using many different mechanisms that we can see here, and also the commercial ones often use picaridin and DIT to block the odor receptors of the mosquitoes. Also, the mosquito repellent is related with diffusivity because they need the diffusivity mechanism to spread along the skin and the clothes to repel the mosquitoes. And also, as we will see in the lab, the diffusivity coefficient it's a measure that it's used to measure the efficiency of the mosquito repellents. Okay, and now for the objectives of this lab, we will develop a protocol to determine the temperature effect in the diffusivity of the mosquito's repellent. As a secondary objectives, we will describe the chemical properties of the of mosquito repellent, that is the mark that we use in the lab, and we will define the correlation between temperature, time, and the height in the container that we use with the mixture, and relate that um, factors to the diffusivity. Okay, now in the methodology, we will explain the real methodology and also the proposed methodology that we had before. We can see the material here. And okay, the steps to follow that we proposed first was measuring. I mean, we had to extract three samples and heat two of them until they reach the objective temperature that we choose to be 50 and 75 degrees. Then apply the samples in the end of the cylinder and check the smell presence when they spread along all the cylinder. Then replicate this whole process three times, and then use the collected data of the times of spread to define the diffusivity and the repellent efficiency. Okay, now for the real methodology of what we did in the lab. First, we have the experimental design, in which we had two factors, the time and temperature, and four levels in each one, meaning that at the end we had 16 samples. And as we can see in the material, we had one small plastic container per one sample. Okay, now for the steps to follow. First, we had to heat three beakers in each one of the heating items and check with the thermometers when they reach the objective temperature. That in this case were 10, 30, 60, and 80 degrees. Then we had to extract 100 milliliters of each sample and choose a specific height in the glass containers. And then take a sample every minute in that particular point that we choose. Then we had to pack every sample that we had in the small plastic containers and then group them in the in the plastic bags. Then we had to evaluate by doing an spectrophotometry test to analyze the samples and define the concentration in each one. And finally, we use the collected data to describe the diffusivity and the repellent efficiency. That a good signal is that in both of the methodologies, we reach the same point at the end.
Now it is time to see the results. So we will be able to see the results of the test with the spectrophotometer to the following tables, which summarize the different absorbance levels with respect to a defined wavelength and how they differ in four different times, 1, 2, 3, and 4 minutes. Finally, you will see four results, since we have results for four different temperatures, 10, 30, 60, and 90 Celsius degrees. And for example, in this presentation specifically, we can observe the behavior of the absorbance levels at a temperature from 10 Celsius degree at the left and 30 Celsius degree at the right. Next, we will conclude from the behavior, but for now, we are showing these graphs. So these are the last two graphs. This time to observe the behavior at 60 and 90 Celsius degree. Quickly for the four cases, we see that as the wavelength increases, the absorbance decreases, and the tendency to decrease sharply was evident in the temperature. So, in a higher temperature, we will have a lower tendency to decrease the absorbance. Okay, guys, these results are not enough. It is completely necessary to conclude with the specific calculations of the diffusivity coefficient. So, for this, we will use our results obtained and we will use the real number equation and the sorted equations to obtain the um, diffusivity coefficient. So I have three steps to obtain the diffusive coefficient, and in the first part we will use the graphs to obtain the concentrations from the substance, how we will use the Beer-Lambert law, and with this level of absorbance, we will of sorry, with this level of concentrations, we will use the sorted equations to finally obtain the diffusive coefficient. Another important factor is the molar absorptivity coefficient, and this is the epsilon term that it is in dimensions from centimeters minus 1, and this is a value of 0.01 in an interval between 400 to 800 nanometers found in literature. Okay, guys, quickly, I want to show you what we made for calculate the diffusivity coefficient, and this is just an application from the steps that we saw in the last slide. So now we're gonna start. The first two important values are the wavelength, and these are special values. Why? Because we extract this information in the maximum level of absorbance. For example, in the minute number one at 10 Celsius degree, we saw the maximum level of absorbance and it was 1.39, and in this level we had a wavelength from 399.9, and in the other side, after 3 minutes, that means at the minute number 4 we have a level of absorbance maximum from 1.45, and in this level we have a respective wavelength from 404.92. Okay, we have the wavelength. So we will use this information to calculate the concentrations. So it is completely necessary to adjust the dimensions from nanometers to centimeters and replace the values of longitude that it was the 1 centimeter and the epsilon that was extracted from literature. So we have the level of concentration at the minute number one and in the minute number four. And finally, we just have to use the Soret equation to replace these values, adjust the values from the time, for example, that was minutes, and we need it at seconds. And finally, obtain the diffusivity coefficient. Um, to finish with this slide, it is important to mention this information. This is our only negative value from this diffusivity coefficient, and we can analyze that it is due to the difference between the temperatures, because in this situation, the temperature from the water is lowest than the temperature from the environment. Specifically, in the environment, we use the standard from 25 Celsius degree, but in this case, the water it is in a temperature from 10 Celsius degree. So we can think that this signal is just from this level of temperatures. But in other cases, we don't have this um, specific situation. Okay, guys, before starting with the conclusions, I want to show you the values of another of the other temperatures. This is the diffusivity from 30, 60, and 90 Celsius degree. So we can start with the first analysis, and it is the behavior between the temperature and diffusivity. And we can note that this is a directly proportional behavior, because when the temperature increases, the value of diffusivity increases. So it is a first conclusion. Another conclusion is the shortest law limitations. And what are these limitations with the shortest equations? Well, we assume that there is no variation in temperature, so we discard this part of the equation. We assume that we are in thermal equilibrium. So we assume that the diffusivity for a specific point from the calculations, which can determine margins of error when we are trying to extracting the samples. Other conclusions is that it isn't possible to apply the fixed two methods, and the explanation at the molecular level why we cannot use Fick's law is due to the flux of momentum. It would be complicated to take the samples and adjust them consistently with molar values of flux. The last conclusion is the presence of various chemical compounds affects the diffusivity on a molecular scale from what we saw in the laboratory and in another information about the diffusion values between the different compounds. And to conclude, to finish, we say that the objectives of the practice were met because we were able to extract the behavior of diffusivity with respect to temperature, and its interactions at the molecular level. So thank you for listening, and see you in another time.